This problem asks us to find the indeterminate form of the limit and then evaluate the following limit. So to do this, to find the indeterminate form, we're going to want to plug in negative infinity to our x's. It's going to look like this. And this is going to lead us to get negative infinity over infinity because a negative infinity squared is going to become positive. And this is the type of indeterminate form this is. To solve it, we're going to want to rewrite the denominator. We're going to want to rewrite it so that it's x2 times 1 plus 6 over x2. And then we're going to want to simplify it by taking out the x out of the square root, keeping in the 6 over x2, and it would become positive because anything in the square root has to be absolute value. And then we're going to loop that. So this is a 3, because 3 times 1 equals 3. X1 minus 1 equals x0, which equals 0, and then 5. And then 5, 0 equals 5. We're going to keep the denominator the same. And then we're going to want to apply our limit so that it looks like this. This is going to give us 3 negative 1, 3 over, this becomes 1, but we keep the negative 1. We're going to get negative 3. Problem, we're also going to want to find the indeterminate form, so we're going to plug in 0 into our x's. So look like this. Sign. Give 0 is going to be 0 over 0. Okay. And then to find our thing, we're going to go straight into applying the loop dal. This means that we're going to want to find the derivative of sine, which is cosine x, and then the derivative of 6x, which is going to be 6. So this is going to look like this. We're going to keep the 6x, so 6x is our 6, and then the 6 over, and then our derivative for the bottom denominator is going to be 2. Then we're going to apply our limit. We're going to get this becomes 0 times 6, 2, cosine 0 is going to be 1, 6 over 2, 6 over 2, which is going to give us 3. And then for our next problem, we're also going to just plug in positive infinity for our x's to find the form. It's going to be like this. This is going to be 0, and this is going to be positive infinity. So this is going to be 0 times positive infinity type. Now we're going to want to solve it. And to do so, we're going to find what we're going to multiply this in here. So we're going to get e 2 to the x, x3, which is going to give us, once we plug the infinity in, it's going to be infinity over infinity type. So we're going to keep going. We're going to add the lambda. We're going to get e 2 to the x times 2 over 3x. 2 is come from 3 times 1 equals 3. 2 times minus 1 equals, or 3 minus 1 equals 2. And when we plug in our positive infinity, we're going to get still positive infinity over positive infinity type. So we're going to apply the L'Hopital rule again. We're going to get this time 4 to the e2x over 6x, which when we plug in the positive infinity to the positive infinity, we're going to get positive infinity over positive infinity type. And then we're going to keep applying the L'Hopital rule. And we're going to get an aex 2x, and we're going to keep going because we were going to multiply this to the initial number. Rewrite that. 2x over 6. We plug in our positive infinity. We're going to get 8 times infinity over 6, which equals infinity. That's going to be your solution to that one. And then for this one, we're going to apply our limit here. It's going to be 1 over 0 to the left, or the negative, and then 0, negative 3. This is going to be positive infinity, because anything that's squared is going to be positive. And then we're going to get a negative infinity, because anything that is cubed, if it's a negative is cubed, it's going to stay cubed. So this is going to be 0 plus infinity, which equals infinity.